Okay, hello everyone. My name is Tormi Lillerand. As I mentioned before in the chat, I have joined you today with a classroom full of audience, and today's topic actually is also really heavily related to agrorobotics. I will give you a brief overview of what we have done in our university. In 2020, we formulated a work group, Agrorobotics work group. What's leader is Professor Jüri Olt. The number of members have been growing gradually. We are expanding. We have a number of PhD students, and on daily basis, when we formed the work group in 2020, we were more into this agriculture 4.0 concept, but as the world is changing, we have to change with the world. We are now trying to implement parts of agriculture 5.0 concept also, and of course active cooperation with private companies. We try to cooperate on these R&D services, try to apply for the grants, projects, try to bring this agrorobotics not just into the university, but to the local farmers and companies. About few projects that we have been working on. Approximately 3 years ago, we received a grant to build our own first farming robot together with this servicing station. Initially, it was developed to precisely fertilize blueberry bushes in the blueberry plantations established on depleted peat fields, but our goal or agenda in general is to offer a fully functional infrastructure, not just the robot for a single operation, but numerous of them and a servicing station for it. So here you can see some pictures of initial building of the first prototype. As you can see, we took just the cheapest possible electrical ground vehicle and adjusted the chassis to match the soil of depleted peat fields. We assembled our own battery packs. Some of you might recognize these prismatic cells, which are manufactured by Samsung. And before we found that they would suit our robot, they were widely used on BMW i3 electrical car. So what made us choose the elements wasn't the fact that if it's good for BMW, it's good for us also, but with these agricultural robots, what we aim is that we want to charge them as fast as possible and have them on the field as long as possible. The second project, it is kind of subsequent project to the servicing station. It was developed based on it, and what we have encountered in many Estonian areas is that, of course, we would like to use electrical vehicles, electrical robots, but there is no suitable infrastructure for it. There are no power lines. And even if there are power lines, then the power outlets might not be available. And of course, if we're talking about the green approach, then what we did was we started to build this mobile energy station, or this power plant. And the idea is that we don't just farm where is electricity available, but we bring the farming equipment there with electricity. In addition to the pre-charged battery packs, what we have there is a set of solar panels in total power of just a bit less than 7 kilowatts. In addition to that, we have this power generator which can run on biogas, it can run on hydrogen, it can run on LPG, you name it, we can make it happen. The power generator is developed in cooperation with our engine lab, and what's our in-house product there is this diaphragm motor, which allows us to use 3 times less fuel for getting the same power output. But as you can see on the slide, it's not only for the agricultural purpose. What we have encountered is that perhaps many of you, at least in Baltic states, remember a few months ago we had this huge amount of hail that caused power going down in multiple areas for several days. With this kind of power station, it would have been possible to at least provide the energy in crisis period, or when I would say important parts of infrastructure are left without power. But of course, the main goal is to bring electricity to places where we don't have it. And important is to also see that when we talk about just agricultural robotics, we often don't need more than just one-phase supply. But once we expand ourselves to military crisis and construction sites, then most definitely we will need 3-phase supply. Here are some images, some renderings, the actual product, and the main construction on it. The construction itself was manufactured from lightweight and tempered aluminium, with its mechanical properties, at least in terms of yield strength. It's comparable to mild steel. So it is strong, it is rigid, and the main idea is that it is lightweight. So what we have implemented, we have encountered extensive lead times, so we had to develop our own infrastructure. We had to purchase laser welding machine to weld the construction, to weld the battery elements. We had to purchase 3D printer for prototyping faster. And with, of course, these research activities, patents should come, and in our case, one is published and 3 of them are pending. let's see, hopefully by the end of next year, we get everything sorted out. About the challenges, of course, I have noticed that they were different between the previous presenters also. But when building the prototypes, what I have seen, the sourcing terms and conditions are really dynamic. At some point, for example, when we were building the top construction of the power plant, within 3 days, the price of aluminium went up by 10%, and within next 7 days, it went up another 20%. This is something that could, of course, outsourcing know-how. We eventually figured it out that it is not feasible in long term, so we start to build out our own competence and put more stress on simulations due to the really limited time window. As if we're talking about these berry plantations, we can only get data and run the field tests within just 3 or 4 months. That's about it. And at least, well, perhaps not in terms of these blueberries, but there's really competitive fields of the research, and patents are coming on daily basis from United States, China, and Netherlands about what we could do different. Of course, already build the infrastructure immediately. First thing to develop these kind of machines, you need to have a proper infrastructure. Make the effort pay. Don't wait, because while we received the welding machine and water jet cutting machine, I don't know, like on second year, if we had them in the beginning, we would have saved almost 5 or 6 months in lead times. Funding needs to be established and secured, not just for one project. And even though I showed how many of us are in the work group, we still need more people to be competitive. Thank you for listening and thinking along.